Hello everyone. Today I am going to talk about the topic regenerative braking system. This is an important technology used in modern electric and hybrid vehicles. In this presentation, I will explain how the braking method works, what components are involved, and how the energy that is normally lost during braking can be utilized again. So, in introduction, whenever a vehicle is moving, it has energy because of its motion. So normally when we want to slow down the vehicle, we apply the brake and that energy is mostly lost in the form of heat. So instead of allowing all that energy to disappear, regenerative braking tries to capture a part of it. So the vehicle electric motor is used in different way during this process and the recovered electricity can be sent back to the battery. So basically, the system tries to make use of energy that would otherwise be wasted then. Now, the question arises, why is regenerative braking system needed? So let us consider a vehicle traveling through a city. It may accelerate, slow down, stops at a signal, and start again many times every time the vehicle slows down. A considerable amount of energy is lost through the normal braking process. So if we can recover even a portion of that energy, we can use it again later. This helps the vehicle use to store energy more efficiently and can also reduce the amount of work done by the normal braking system. So now let's see some basic concept of it. So to understand the concept, we can think of the electric motor as having two different roles. When the vehicle needs to move forward, the battery supplies power to the motor and then the motor turns the wheel. When the vehicle needs to slow down, direction of the energy flow changes. The rotating wheels now make the motor rotate and the motor behaves like a generator. While generating electricity, it also creates a force that opposes the rotation of the wheel. Because of this opposing force, the vehicle starts slowing down. Now, let's see the main components of regenerative braking system. So there are several parts working together to make this system possible. The motor is the main part because it is responsible for both driving the vehicle and producing electricity while slowing down. The battery is where the recovered electricity is stored, and between the motor and battery, electronic circuits control how electricity moves between them. There is also a control unit that decides how much braking should be applied. The battery monitoring systems make sure that the battery is operated within safe conditions. So finally, the normal mechanical brakes are also present because regenerative braking alone cannot handle every braking situation. As there are the main components, traction motor, battery pack, inverter or power electronics, vehicle control unit, battery management system, that is called in short form BMS, then friction brakes and wheels and drivetrain and wheels, motor, generator, inverter and then battery. This is the cycle of it. So as you can see in this image I mentioned in this. So let us see the main part of this regenerative braking system, that is working of regenerative braking system. So let us see what actually happens when the driver wants to slow down the vehicle. Imagine the car is traveling on the road. When the driver takes the foot off the accelerator or starts braking, the vehicle electronic system recognizes that the vehicle need to slow down. The electric motor then changes its function and start behaving like a generator. Since the wheels are still rotating, they turns the motor through the drivetrain. The rotating motor produces electricity and this electricity is controlled by the power electronics before being supplied to the battery. At the same time, the motor creates resistance against the wheel rotation, which helps the vehicle to slow down. As you can see in this image, so we can see that the wheels are not completely losing their energy. As part of that energy is being converted into electricity, is sent back to the battery. If more braking force is needed, the normal brakes are also works along with its system. Let us see energy recovering and blended braking. So the amount of energy available in moving vehicle depend on its mass and its speed. So when a vehicle is traveling faster, it has more energy associated with its motion. During normal braking, most of this energy ends up as heat. But in this system, some of that energy can be converted into electricity and returned to the battery. So as we can see here, kinetic energy, convectional energy, braking, and the regenerative braking. Now let's see blended braking. So however, the electric system cannot always provide all the required stopping process forces. For example, if the battery cannot accept more charge or if the vehicle need to stop very quickly, the normal brakes have to assist. When both methods work together, we call it blended braking. This gives the vehicle both energy recovery and sufficient stopping performance. So now let's see about advantages and limitations of regenerative braking system. So let's see advantages. So first, it recovers braking energy. Second, it improves vehicle efficiency. Third, it can increase EV driving range. Fourth, reduces brake pad and disc wear. And fifth, reduces the heat generation. Sixth, can reduce maintenance. And seventh, useful in stop and go traffic. Let's see the limitations. Cannot recover all braking energy. Second, energy losses occurs in the system. Third, limited when the battery is nearly full. And fourth, battery battery temperature can restrict charging. And sixth, less effective at very low speed. And seventh, conventional brakes are still necessary. Let's see the application of this regenerative braking system. So this technology is not limited to one particularly type of vehicle. It is commonly associated with electric car and hybrid cars. But the same principle can be used in many other electric transportation systems. For example, you take electric buses can recover energy whenever they slow down at stop. Electric two-wheeler can also make use of this method. Trains and metro systems are another important application because they repeatedly accelerate and deaccelerate. It can also be useful in electrically powered industrial vehicles. So finally, we can say in conclusion that regenerative braking is a smart way of making better use of energy available in an electric vehicle. Instead of allowing all the energy of moving vehicle to be lost when it slows down, the system converts a portion of it into electricity and send it back to the battery. This can improve the overall energy utilization of the vehicle and reduce the dependence on mechanical braking. At the same time, conventional brakes are still important whenever stronger or more immediate stopping is required. So we can say that the regenerative braking converts more energy that would otherwise be wasted into useful electrical energy, making electric and hybrid vehicles more efficient. So now to understand this process more clearly, I'm going to show you a short video. This video shows how regenerative braking works when the vehicle slows down and how the energy is recovered. So let's see the video. Thank you, everyone.